Let's talk a little bit about how QNI works, particularly on version 7.5. So in order to do that, let's review how standard QReader works. So most of you are familiar with QReader collecting logs from things like Active Directory, Windows logs, any app, firewall logs, etc. Right? And those logs are processed by QReader wonderful rules, and that's what performs the correlation and finds things that are out of place, and that yields offenses that invite you to investigate what is actually going on. That's pretty basic stuff. Now, here in my QReader system, if I go to the use case manager and I have more than 1,000 rules, if I click here on the type rules that works on events or logs, we get quite a few of them, 800 and so. Now, you probably remember that QReader can also get either from a tab or from the router. It can get the net flows, and again there are QReader rules that find things that are out of place, things that should not be happening, and they also contribute to offenses. In fact, you can have in one offense, you can have both logs and flows contributing to the same offense. Back to the use case manager, if we were to search for only the rules that work with flows, we find about 100 and something rules that find things that can only be found by looking at the actual network traffic. Now, QNI from a tab on the network works in ways similarly to the other two components. So there are some QReader rules that can also fire offenses. Let's go back to the use case manager and find those. So out of the rules that work on flow, if I, for example, add a filter here that looks into the names and the QNI rules that come out of the box, come with that prefix, we see a much smaller number of rules. Still, find some things that are abnormal, but there are not that many rules, and that's not the way that QNI leads with, which is with rules, because there are so many things that can be inspected from the network, and for every company, things are going to be different from one another. So even though those rules still play alone, they play a smaller role. One of the things that QNI is very unique and very useful is that it automatically computes the hashes of any file going through the network. And let's say, for example, that you have a reference set that is fed with stick and taxi feed from your favorite thread provider, and you have file hashes of things that are bad. So you can also in that way get rules that will fire offenses when one of those bad file hashes are present. And you don't have to have logs for any of these. If the traffic is actually going and there's a malicious component that can be identified by its hash, then you can actually get easily set up rules in QReader for looking for that. But another even more important component is what is the capability of QNI of automatically find suspect content. Let's actually see that in my demo system. So if we go back to QReader and look at the network activity, and the search I'm going to make, or the filter I'm going to put, actually I have it saved in a search here. Basically I'm saying go ahead and look, and I'm going to go back 30 days and find anything that QNI has found with the suspect content description with something in it that is not NA, right? And that can easily be done by you clicking add a filter, and you put here suspect content descriptor equals to not NA, right? So I have the search already done with some of the fields being, some of the columns being populated in here, and it finds things trivial like somebody's using a self-signed certificate, which today is a very rare event. Everybody can get free certificates and do the things a little bit all right. With things that are a little bit more problematic. So let's actually go into these events in here. So if we look at those, we can see all these three, and if we go into one of them, notice that, as I mentioned in the previous recent video, the many components have now the link to the X-Force to tell you what it is. So if you don't know what this type of strange behavior or suspect behavior is all about, you can click here and find that that's doesn't seem to be that malicious, but it really explains you what this is. Somebody's probing your ports to see what's available. And you can go into things that are a little bit more serious, like this one that has been found. If we go to one of these events, we notice that this one actually fire offenses. This is a more serious type of event of medium intensity. If we go back and find, for example, this one, we see we have one event, and if we click on it and go to the description of this X-Force issue 509 certificate, this is actually people dealing with a forged certificate. You can actually get the details there. So only by just having QNI and without relying on any of the rules or hashes or the things that we said before, the suspect content, a search like this can lead you to find things that are actually malicious. And this is actually some bad traffic that I replay the PCAPs from, and so the tool actually found them. There's also another component in QRadar, which I'm not going to talk much about it today, which are JARA rules. And think of these as, okay, I want to locate particular words in documents on my network. Is that capable? Things that are specific that you want to watch for that has to do with the nature of the business that you are in, you can build JARA rules that in QNI will work for you in that. Now, some people may say, well, I don't like this idea of QNI because most of the traffic these days is encrypted and QNI cannot see anything about it. Well, not quite true. It is true that when the traffic is encrypted, QNI, unless you do man-in-the-middle interception, which probably you should do, but not always work, and not always you can do it everywhere without breaking things. It's true that if the traffic is encrypted, the visibility of QNI is very limited, but let me talk to you about JA3 and SSL hashes. And what this is all about is that somebody figured out that the way that when you perform the initial negotiation of the protocol exchanges to generate an SSL session, everywhere you go and every component that when it initiates an SSL session, if you were to take all those steps, all the data that was in the, what algorithm are we going to use, what is my IP, URL, all those things, and you hash them, you can identify unique malware, unique going to a specific site, and things of that nature by virtue of that but that hash that does give you some level of uniqueness. It's not fully unique. I mean, if you and I go to the same site, we may get the same hash, but it's pretty unique. And this is particularly important when you are doing things like in AWS, that you cannot have all the firewall capabilities that you may have on-prem. And in fact, let me actually show you right now a link to a document that describes how you set up mirroring traffic in AWS. And here's the document I was looking for. If you Google traffic mirroring and QNI, you're going to find this instruction that tells you how you set up all this visibility in the cloud, where you may not have, or most likely don't have, all the firewalling capabilities that you may have with your Palo Alto or Checkpoint, or the things that you typically have on-prem. So if you were to search for a parameter, you're going to put the word JA3. So this is the client is JA3 hash and the server is JA3S. And it says, show me anything that has JA3 files that had been collected in QNI for the last 30 days or so. So here you can see some stuff that is malicious in nature, and clicking on any one of those, and you'll find in here that of all the data that was actually collected, there's the JA3 in here. And if you have, and I'm going to do a separate video that shows the beauty of this on a post that Dale from Australia did, that shows you how you can collect bad JA3 hashes. There are organizations that provide you that. And I'll show you how you get those into QReader in that video. But this allows you to, in the same way that you search for hashes on things that you have network visibility because you were able to tap into an unencrypted part of the network, this will work in spite of all the traffic being encrypted. So you have visibility even when the traffic is actually encrypted. Here I have another example in which I did some searches, and again on that video I'll show you how all these can be set up, in which I have a reference set that is being fed by the abuse.ch people that has malicious traffic. And this is actually an instance of the Cobalt Strike tools getting into the wild and actually being used. And this is actually my hometown in Venezuela that this attack actually took place. But you can see the certificate that has the fingerprint of the actual certificate. Again, in spite of this traffic being invisible, allows you to see things in QReader. And notice that this is the address that ends in 103. If I go to my Network Threat Analytic app, which is a free app that works with standard flows but really leverage tremendously QNI logs, we can actually see that this is the machine learning. What is it that is not normal that we have not seen on your network? This is what this help you. We actually see that IP address messing around right there. So it actually caught both. So I hope that this gives you a better understanding the value that QNI brings, and how it complements things that we do with standard logs and net flows in QReader.